So, in this video content, you will understand how you can create your own speedometer within QML on a Raspberry Pi. Also, you have an idea how you can interact within hardware with your application. It is highly recommended that you can follow the old video content to create your own development environment for Qt and Raspberry Pi. Let's create a new project with a Qt quick application. It's an empty application, give a name as speedometer, whatever you want. The whole example code is available in the GitHub link. You can find the link below the video. I choose both the Raspberry Pi and a desktop environment first, and I will simply create an application on the desktop. Then I will add an hardware dependencies for the Raspberry Pi that we will see in the video in release mode. As you see, let's compile, and it gives an empty QML window simply. And actually, what we will do, we will add a QML speedometer type. That is why we need to create a new class as the name as a speedometer, and include a QObject. With QObject, you can enhance the C++ introspection feature in Qt. So you can simply connect with QML part, with the JavaScript part, with the C++. Simply you can send the data from C++ to the QML to the JavaScript side that we will do in this tutorial. And also it's called actually the runtime type identification. You can find more information in the internet. To that, we have to define the QObject in the class, and we use the Quick item, painted item. We have to inherit it. There is a virtual paint method we have to implement. Otherwise, it will give an error, compiler error. And also, it's a good idea to write a quick item here. So then in the CPP file, we have to implement the methods. So also the inheritance for a painted item class as a parent. Then as a void methods, we will draw the things in the paint method. We will see in the later. So include the speedometer header file. To connect with QML, we have to create a type. We have to register the type. The way I follow last method speedometer. This is the 1 and 0 minor and a major version. A speedometer is the name which is used in the QML. You can choose whatever you want as a name. There is some problem. It's not imported. It is not working right now. I think, we forget. Same. Let's run QMake again, and no, okay. There is no type. Okay, I forget to implement a type. Yeah, as a speedometer. Now it should work. Let's remove, I think, the whole and add again. Yeah. Now we can write, yeah, speedometer is an appear. For example, we can add in the text. It is an empty right now, speedometer. Yeah, there is no problem. As you see, our type is created, and we can talk with the QML right now. So we have to implement a property. There will be something around a few properties we will create. First, we have to give the type and a name. Speedometer size is the first type, first property. Then should be also get speedometer size. We have to implement the get speedometer size method, set speedometer size method, and also we have to define actually speedometer size change and as a signal. So we have to again run a QMake. Oh yeah, it says it needs a signal. We didn't define. It gives an error. So let's simply define the methods, set and get methods, the QReal size. As a private, we'll create void speedometer size change. And There should be an implementation in the CPD file. For each property, we should implement the set and get methods. Set speedometer size, real size. It should be signals. Yeah, this is wrong. As a private, we have to implement the variable, member variable in the class. If the speedometer size is equal to size, I will just return. And if it's not, I assign the member variable. Then after assigning the member variable, it's an idea to emit the signal. If you emit the signal, then the QML site will work. When you emit these things, the QML site, you update the value. I just simply return the member variable of the speedometer size. But the types are, I think, wrong. Yeah, types are wrong. Real, and this will void. Now let's recompile again. Yes, there is no problem. And now, yeah, as you see, we can see the speedometer size property in the QML site. Good. So now, with this single property, we will have a bunch of properties that I will write down right now. It's in the copy. I will not bother you for each. There will be start angle, align angle, lowest range, highest range property, speed property, arc width property, outer color, inner color, and text color, background color property. So for each property, there will be get and set methods, and also the signals, and also the member variables should be implemented. So we can actually initialize the variable in the constructor. I just give a speedometer size of 500. I just calculate before these things. Start angle 50 and align angle is around 260. Lowest range is 0. Actually, it is the lowest range, yeah, is 0, and the highest range is 4000. That is related with the analog and digital converter that I will simply align this number. You will understand what I mean in the next. And this line angle should be 360 minus 2 times start angle. It will look good in this way. And also I just initialize the speed, doesn't matter. We will change dynamically. And arc width with 10, outer color, you give whatever you want. I give, and this one I calculated before, which is an around blue. And inner color, there will be also transparency, is there about the blue. Text color is white, and the background color is transparent, doesn't matter right now. So we can start to paint something. We will use an QRect. This is for initializing, and we use directly the painter set rectangle. Actually, it's a good idea first rendering as a anti-aliasing. So I forget the painter here. Also, we need a pen to paint, to draw the things. Cap style, you can give whatever you want. I just using a flat cap. Now I create a start angle and a span angle. Start angle will be equal to member variable of the start angle, but it's not exactly the same. We will change the coordinates, rotate. I will show you in the next. we have to calibrate the size, we have to calibrate the rotation. But I think, yeah, I forget the set get methods for each member variable. I have to add. I will write all of them. So the only thing here in the speed, there will be update method. So when the speed is changed, all drawings will be updated. Not when this height range is changed or the color is changed, drawings not updated. Okay, when the speed is changed, drawing will be updated. This is the thing. If you want to update the drawing, if you want to update the paint, you have to change the speed. So we will change the speed dynamically. So for all arc, there will be outer arc, and just set width and a set color with an inner color. These also parameters can be changed from the QML side. Also the C++ side. This is the future. This is the power of the Qt. And also with the draw arc method, we will just use the coordinates of the rectangle. In this rectangle, you don't see, this is a virtual rectangle actually, then in this rectangle, we will draw a lot of things. So we need rectangles first. We need coordinates, we need restrictions, we need lines. 16 coming from the theory, this methods. We have to restore after each drawings. Should be painter. And what is the correct? Okay, this is T. I forgot. Let's compile. Let's try. No, there is nothing. There is some problem that I don't see. Let's check. In the QML side, the variables is not initialized. Is not implemented. This should be initialized in the QML side. So import the Qt control. Also Qt layouts. So in debug it's working. Now let's try again in the release mode. As you see, speedometer for the outer arc is drawn. The position is not correct, right? So we have to rotate the arc. To do that, we have to change start angle. I just give the 400, actually not 400. Start angle should be start angle minus 40. That I just change with trying a lot of things. You can also try and change whatever you want. Let's try again. And as you see, yeah, the coordinates looks good right now. The position is correct. So first, the next thing actually, that's drawing the inner pi. Yeah, pi size will be the speedometer size divided by 5. And also you can draw the rectangles with a draw rect to understand better. For example, for the first drawing, that you will see the rectangle, right? The outer rectangle, we draw everything inside this rectangle. So I will make the comment. So set width, we have to set the width of the pen and also the color of the pen. And now the painter, for a painter we have to set a brush that will give a color inside of this pie. We have to set a pen again for a painter. Then now we can draw the pie with the same idea, the rectangle adjusted. I just give the coordinate of the pie size. I just give the coordinate of the rectangle actually. Then it's the same with the start angle and span angle. And we have to restore again every end of the drawings. Then as you see inside the outer arc, there will be there is an actually simple pie. So actually it should be the color is not correct, I think. I want to make it something like a yellow one, whatever. So the next step will be about the text. We should draw the text inside this pie. We use the Q font. I just use a Helvetica 52 and Q font and bold. You can change whatever you want. You can try. We just pass this font just painter fonts. Then we just set the color of the pen, and we pass this pen to the painter. And now we draw text with the draw text method simply. And now this is not exactly the same with the draw pie and draw arc. This is a bit different, but we have to again adjust the rectangle. The size will be, I calculated actually before, will be like this. You have to re-coordinate everything again. Actually, no, this is wrong. It should be not like this. I just align the center and give the number for text. What should be C? Number, what you want to see. So one parenthesis is missing, I think, there after number, right? We have to restore again. Let's draw. But before, yeah, you can change the color, the other color. Yeah, the green lines, but this position is not correct again. Let's check again. No, this is not still. That I think it should be 4, not the 40. Right. That's better. So the next one is the current process. We have to draw current active process. We again save the painter. Then we set just the pen width. Then after that, the color should be set. Then we calculate the angle of the speed. So we just the current speed minus the lowest range divided by the highest range minus a lowest range. Then also we have to multiply by the span angle. Then we just set the pen and we draw another arc. That is all what we did before in the first thing. This is minus. I just draw the rectangle, all the rectangle, and start angle times 16, and value to angle times 16. And we will restore again. And we should pass. This should be painter. Run again. Yeah, as you see, it's not a dynamic right now, but we can change the value here. See, it's working. So now it's time to change from the C++ side dynamically. So to do that, we have to reach the property, actually component from the QML. Simply we create a Q object, and from this Q object, we will find the child as a speedometer that is from a font, the object name we gave before in the QML, which is a speedometer actually in this example that is here. So simply from the pointer speedometer with a dynamic cast as a speedometer type, we can simply cast here, but also dynamic cast is working, but I will use the Q object cast. So it is now working. We just find out and we get the address of this instance, speedometer instance, which is created in the QML site. Now that means from the pointer speedometer, we can access the methods of the speedometer class, right? For example, set speedometer size. See, this is really good. This is perfect actually. From the C++ side, we will update the QML properties. And I want to create a dynamically in a loop, with creating actually the timer. I will simply connect this timer to the timeout. You can simply write or implement the lambda expression. That is a more portable way to implement the things. I just simply, like this, increment step by step to value. You can start a timer. Let's check. See, speed is increased dynamically right now. This is really good. Once that it's slow, we can increase the speed. To test a little bit also, we can add some more things here. For example, we can change the color according to the speed value. We have to implement the direction first, because when it's the speed is in the maximum value, I will go back this value dynamically. I want to increment it by 10 simply. Let's run again. See, after maximum value, it will go back, bouncing simply. Now, to connect to Raspberry Pi hardware, I use actually to connect to LTC 2400 analog digital converter. I use SPI communication bus. From Raspberry Pi, I will use a wiring Pi library. To compile in my host machine, I will copy this shared object file from the Raspberry Pi, and I add this to this project as an external library. Then I can compile this project for a Raspberry Pi, for an architecture in my host machine. So that's simply connect to your Raspberry Pi with an SSH. Just find where is the wiring Pi library. This is wrong, lib should be. As you see, is USR under USR lib. This copy just this SO file into your directory, project directory, whatever you want, whatever you choose. So as you said, you cannot check the dependencies, but you can check this file. It is an ARM. This is different architecture. It is used. So that is why we cannot compile for our architecture in the host machine. So we have to change for ARM. So add the library. Just go and find this library for just only Linux, and it will add in the profile this lib wiring. For Raspberry Pi, we can compile right now. But there is some problem, I think. It is not working. I cannot see the library. It is added correctly. There's something wrong. Let's run Qt again. No, there's some problem. As I checked, I choose wrong an application binary interface for Raspberry Pi. It should be ARM here. Yeah, now it will see. So we choose the channel. There are actually two channels in the Raspberry Pi for SPI.
Hold on a second. What is an LTC 2400? It's a simple analog digital converter, right? But it has a high resolution. It's about 24 bits. That means we can see really small changes in the analog signals. So it's working within 5 volts also. That also you can find more information in the datasheet about a communication protocol, which is an SPI here. And here also you can read. As you see, there are 32 clock signal, 32 bit. And also here. And the STO line that are with 31 bits. That is why we will read 4 bytes, right? So you can use another analog digital converter for Raspberry Pi, but I use this because of this its high resolution. As you see, from here. And also it uses delta sigma technology. And this is the circuit diagram I use for this project. You can check. So let's return the project.
I found this sample code on the internet. I just simply set up wiring SPI with a channel and then this frequency of the SPI bus that I will use. LTW0 is just a voltage value I will use. I just create a new timer. Connect the timer with this method. Lambda expression actually, it's not a method. So I just read to write SPI function. I will actually read 4 bytes because in the datasheet LTC 2400 it says that there are actually 4 bytes. So I have to handle the 4 bytes to read the value. LTC 24 is a 24 bits analog digital converter, which means it's really high sensitive. I just read the buffer. I want to read only just a voltage value, but not a real voltage value. It's the analog value. So that is why I divide by 16 and I multiply by 4000, which will be the same with the maximum value of the QML site. So I start the timer. Let's compile. Before compile, I have to assign val to volt. Val is equal to volt. It's compiled. We don't need direction right now. When you change the value, let's leave the val incremented by some value. This will be looking more better. You will understand at the end when you see the example. As you see, we can set the other color from here, from C++. This is called introspection. When it's greater than 1600 and lower than 300, 2300, and I change the color. And if it's greater than 3200, I change color again, which will be red, and that will be val. It's wrong. It should be volt. So there is some problem again. I forget thing. It's compiled. Great. So we can send the binary to the Raspberry Pi. Speedometer, this is for ARM. So let's copy this binary to the Raspberry Pi and run it. Let's see what happens. You see, there is no sharp change. See, there are smooth changes. When you increase or decrease the speed, the value, this is not directly assigned. So when it's assigned directly, there will be sharp change. This is not what I need. I will need a sharp, not a sharp thing, a smooth movement, right? That is why I increment by some value. So thanks for watching. For me, this is all. All the examples you can find in the link below the video. Don't forget to subscribe. See you again.